So we've talked about the three cases previously, but now we have a little more terminology. So when we have a line, we have a system of equations and we graph one line, and then we graph the second line and it's really just the same line. Those are called coincident lines. So when they're the same line, okay? The solution, and this is tricky because they usually ask for the solution, but the solution is there are an infinite number of solutions. So that's what you're going to write, or if it's a multiple choice thing, you get to pick that. So there are an infinite number of solutions. A consistent system has to, let me back up to the coincident lines. Coincident lines have the same slope, and same y-intercept. They are the same line. So if you put them in slope-intercept form, they're going to have the same slope and they're going to have the same y-intercept. A consistent system has at least one solution. So in a picture form, it could be the coincident lines, like we just had, where they're the same line. Or it could be the case where you have lines that are intersecting. Okay, those would both be consistent systems. An inconsistent system has no solution. And so that's when you have the parallel lines. And when they say to solve, you're either going to put no solution or you can put the empty set. The empty set. Okay, so again, you'll know if they're parallel or if they're coincident if you put them in slope-intercept form. Y equals mx plus b. A lot of times students remember that. So that's going to be the key to this next problem. We're going to just put them in slope-intercept form. So it says, without graphing, determine the number of solutions and then classify the system. So the first equation, well, that's already in slope-intercept form, so nice. The second one, we're going to have to rewrite it. So take the 4x to the other side. 2y equals negative 4x plus 9. Divide everything by 2. And you get y equals negative 2x plus, you can put 4.5 or you could just leave it 9/2. So what are we looking for? Well, do they have the same slope? So same slope? Yes. And then you have to go another step and say, do they have the same y-intercept? No. So this one has a y-intercept of negative 4, and that one has a y-intercept of 4.5. But you can see the slopes are both negative 2. So the slopes, that was a negative 2, and that was a negative 2. So yeah, that's where the yes came from. They had the same slope. They don't have the same y-intercept. So what does that mean? It means they're parallel lines. So these are parallel lines. Now, it says, without graphing, determine the number of solutions. Parallel lines have zero solutions, so 0 solutions. It says the number of solutions, 0 solutions. And to classify the system, it's going to be inconsistent. Okay, so that would be your answer to this problem. All right, let's go to the second one. Well, neither one of them is in slope-intercept form. So if I take the top line, put the x on the other side, I have 2y equals negative 3x plus 2. And then I divide everything by 2. and I get y equals negative 3 halves x plus 1. Okay, so that's one equation. And now I'm going to switch colors so I don't get my equations mixed up. If I put the x term on the other side, I get y equals negative 2x plus 1. So are the slopes the same? So same slopes. No. So they don't have the same slope, so they're not parallel lines and they're not the same line. So, I mean, you can ask yourself, do they have the same y-intercept? Yes, but in order for it to be the coincident lines, they have to have both the same slope and the same y-intercept. They have the same y-intercept, but that's not going to matter to us. So they don't have the same slope, they're not coincident, and they're not parallel. So this has to be the, it's a consistent system. Consistent. Oh, and it has one solution. One solution. So if you were to graph it, it would make two lines that intersect. Okay. So how do we know again it's one solution? Well, they don't have the same slope. They're not coincident lines because they don't have the same slope and they don't have the same y-intercept. Well, they do have the same y-intercept. They don't have the same slope though. Anyway, they're not the same line. So it can't be the infinitely many solutions. And they're not parallel lines because they don't have the same slope. So your only other choice is it's a consistent system and there's only one solution.